Hello everyone, welcome to AI Anytime channel. In this video, we are going to see how we can use Qwen-2 vision language model, combine that with ColPali, which is basically a backend engine to inference, run vision language model. There's a different architecture. We're going to talk about it, and we're basically going to, ask some questions from, PDFs that have images within it. Not completely multimodal in a sense, but if you have documents which have n number of images and you want to find out or ask questions related to images, which is not of course explicitly defined, how we can do that. So for these kind of use cases, you need a vision language model that can understand images through an image encoder. And of course, you need to basically use some kind of orchestration for that particular orchestrations, like creating the basically indexing the documents and images, so on and so forth. We're going to use ColPali in this video. Let's jump in and see how we can do that. Now, if you look at here on my screen, okay, already have, you know, uh, Colab running. Okay, I'm on Colab Pro and I'm using A100 GPU. This will not work on a free version of Colab. Okay, you need a Colab Pro to work with. Either you need L4 GPU at its minimum, or then you need A100. Okay, and you can see I already have installed transformers from the source, from GitHub. I'm using ByLD. I'm going to talk about it. We have accelerate, flash attention, just because we want to handle the computational requirement of while we are inferencing the LLM, and we want to make it a bit faster. We have Qwen-utils, a module that Qwen library provides, Qwen-VL, vision language, and PDF to image. I have 3 videos on Qwen-2, one of my favorite models when it comes to any use cases where I'm dealing with vision and there's a requirement of open source. I use Qwen-2-VL for that particular use cases. Popular utils. If you don't have popular utils, you can't work with PDF to image on a Linux machine, unfortunately. So if the PDF to image library that you see it over here, it requires popular utils as a backend. I think Ghost script and popular utils are the two backend engine, if I'm not wrong, as far as like my knowledge, for PDF to image library. Popular utils pretty easy to install on a Linux distro. For example, if you look at here, Colab uses Ubuntu in the backend, so we have pretty simple installation. If you're on Windows machine, you might find a bit difficult. Now, we're going to use Qwen-2-VL-7B Instruct, the instruction tuned model, okay, of the Qwen-2 vision language that we have over here. And I already have a PDF thingy. So if I just click on that PDF thing that you see, let me show the PDF. Now you can see there's like this is a case study this is an oncology case study from Massachusetts General Hospital. It says gastroesophageal surgery case. Sorry, I'm not a doctor, so pronunciation might be a bit up and down there. Okay, so you can see a 76-year-old woman with stomach cancer, and the case study presentation of case have bunch of images, and I'm going to talk questions only related to these images. Text-based questions answerings are pretty easy. You have, like, we have been building, my channel itself, we have 50 plus RAG videos now, but the idea here is to see how we can use this in a, like, when you have multimodal, different dimensions of data within your, your data corpus that you have, how we can use some kind of pipelines, to basically handle those. So if you look at here, we already have installed. Now this will act as a large language model, and then we need ColPali. ColPali is amazing. Was really impressed. It says efficient document retrieval with vision language models. This is fantastic. you know uh, I can see it over here why I'm using ByLD, because it says for production uses in your RAG pipelines, we recommend using the ByLD package. It's a lightweight wrapper, around the ColPali engine. That's really good. There's another other package that's developed by the same author, which is RagToli. That is also fantastic. But if I click on ByLD here, it takes to the ByLD GitHub. It says use late interaction multimodal models such as ColPal in just a few lines of code. So basically, high level abstraction, guys, because we are so busy nowadays in the work that we do, we probably don't want to write hell lot of code. It's everywhere. When we get errors, we go into ChatGPT and say, okay, fix it. Earlier, we used to search on Google or Stack Overflow or some other communities channels, but now it's like ChatGPT. And for the obvious reason we don't want to write a hell lot of code. That's why if you can see libraries where these wrappers and abstractions and the orchestration frameworks are coming up, and ByLD is also one of the example for the same. Okay, if you look at here. Uh, so ByLD combined with ColPali. Okay, you can look at the ColPali's architecture. If you open the image over here, probably let's do view raw. Why not? Okay. Now document. So how it works, guys, in a vision language model, when you have a multimodal model which has a image encoder, and of course, when you deal with the text, so text is of course there. There's some kind of model that of course you can use, but for the vision encoder, for example, siglip can be one example, or clip is one example. There are a lot of other models that can be used as a vision encoder. So when you give a document, the vision encoder first looks at that particular document, and then it creates some projections, then pass to LLM, and then find out the similarity scores, blah blah blah, and then we also have decoding part of it. So this is the ColPali architecture. Okay, let me just go back over here in the GitHub repository, and if you come back, you can find it out there: introduction, the setups, how you can want to set up, and pretty much everything. Now, document you saw that this is the document that we're going to use. You can have n number of documents within when you are creating the indexes or indices for this. I'm going to talk about it. So, guys, combining ColPali, ByLD, and Qwen-2-VL-7B are pretty good, kind of a flow, to work with. So let's just jump in, guys, and start doing it. So what I'm going to do is I'm going to say from ByLD, and you can import. ByLD provides they provide a module for multimodal RAG kind of a thing. So that's you can get that RAG multimodal model over here. You can see. Now you need to import this. You're going to import a few things from transformers. So from transformers, import Qwen-2-VL for conditional generation. So let me just do that as well. So from transformers, import Qwen, Qwen2VL, Qwen2, and you can see it's showing me over here. Let me just write VL so it will show me for conditional generation. And then we're gonna need auto tokenizer and auto processor. So let me just do auto tokenizer uh, and auto processor. Excuse me. Yeah, auto processor. That's what we need from transformers. Now we need, so you're gonna need vision. So Qn2, Qn2 utils provide a module called vision info or something. So what I'm gonna do is from Qn2, yeah, you can see Qn2, not Qn2, it's Qn VL utils, and then I'm gonna import uh, process vision info. So we need this PDF. Of course we need torch. Without torch, how will we work? Import torch, and then from PDF to image we need convert from path. So what I'm going to do is from PDF, yeah, this is fine, and import OS. Now let's just get this thing. So you can see our import is successful. We can probably rename this document. Okay, that's like, let's make it docs or something. Docs PDF. I have PDF. You can keep n number of things. Now let's create a variable called RAG engine here, and within this, or you can also call it RAG model or whatever. Or let's call it RAG engine, and then you're gonna use RAG multimodal model. It was not suggested, by the way. It was suggesting me only modal. Okay. Now the way you would use from pre-trained from transformer, same way you can also do it with ColPali. Now RAG multimodal model dot from pre-trained, and then we're gonna bring the model. Okay. So the model, if you come here in ColPali as well, yeah, you can see this is the model name that we need. Okay. So I'll just gonna copy. I don't need 1.2, even 1 is good, but you can also take the latest model. So let me just get that here. Vidor ColPali, and you just now define RAG engine. After you define RAG engine, we need the the vision language model. So what I'm going to do is, let's call it VLM, which is your vision language model, and I'm going to use Qwen2 for conditional generation. Bunch of things that it has given. Okay, now that we're gonna do from pre-trained. So let's just do from pre-trained, and within the from pre-trained, we're gonna pass a bunch of things over here. Now Qwen whale chat. No, not that. We don't need that. Okay, but come over here. and just copy this thingy. You can also define in a different way. And then, okay, what I'm gonna then need is I'm gonna need torch D type, and we can use bfloat16 because we are on an Ampere architecture. So if you look at here, we are using A100, GPU. If you want to use BF16 or bfloat16, you need an latest NVIDIA architecture or an Ampere architecture. Okay, so be mindful of that. So I'm gonna do is torch D type, and within torch D type, you're gonna define your. You can see it's showing me torch bfloat16. If you don't have, then it's go with F16. Don't use BF16. Okay, so now that is fine. We're gonna get rid of, I think, almost all. Okay, now torch D type, torch dot bfloat16. Now as we are using flash attention 2, uh, we can use attention implementation. So what I'm gonna do is attn. Why it's not showing me implementation? So we need attention implementation. That was, you can see Triton. At least it got it late. Okay, what the, that's the problem. Okay, we don't need Triton here. Okay, but you can, if there's a requirement of Triton backend engine, you can also do that. For here, I need flash attention too. So let's just get that thing done. Flash attention too. This is what I need. And to, not hyphen, underscore flash attention to. And what else? We need device map. As we are on GPU, we can just bind it. We can bind the CUDA to, yeah, device map. We can bind it to CUDA. So let's just do that. Okay, now we have our VLM defined. We have our RAG engine defined. Now we can just run this. It will take it can take up to few minutes depending on the internet bandwidth. And also let's just run it and see what happens. Whew. Okay, now taking a bit of time, guys. Meanwhile, it's gonna first download all the safe tensors, the sharded weights, and then you're gonna load it. Now what I'm gonna do is I'm gonna now the next is we're gonna create an index. We have to index the document. Okay. Now you can create a directory and you can put n number of PDFs. Depend, of course, you have to see your processing power and the computational speed is computational power that you have. It doesn't mean that on a very limited compute you can bring up 100 document. It will crash. It will not work. So here I have single document, but you can have at least 10 to 12 documents if you want. To try it out on A100 on Colab, with of course number of pages also depends. Now what I'm going to do is, you can see it downloading the shards right now. Let's create the index and see how we can do it. So we call it RAG engine. If you see it on top, now RAG engine dot index. Okay, so you can see it index, and when you do the index, now it says input path is string path. Now the input path should be the data path that you have, can be a directory, can be a single file, whatever you want to do it here. Now in the input path, I'm going to have my PDF. So let me just do input path equals, and I'm going to pass my docs.pdf. Now you can also bring up your directory, and you can have n number of documents within the directory to do that as well. Now here after docs PDF, now this is fine. Okay, let's the model thing get done. You can see it's almost done. It's now loading the checkpoint starts. That's the main important thing. It has to load in the memory, the GPU memory. Next is index name. So you're gonna give a name of the index, and you're gonna call it anything you want. I'm gonna call it like index or something, which they suggested. It's pretty much simple, guys. You should just know how it's gonna work, the workflow. Because to be very honest, in today's world, things are really simple, but having a complete fundamentals knowledge are always important. Now, if I'm writing this code, these are not my code, to be really honest. Okay, it's nobody's code. It's the developer who have created this, libraries or frameworks. They give all this documentation, so on and so forth. So you have to be very attentive, looking at these documentations, the GitHub repositories, and see how the flows have been created. But the fundamentals knowledge are really important, to understand how it's working at least. Now, index name equals index. Now, it also has uh, storing the collection with an index. You can see, but you can make this false for now. So let's just do it false. And then it also has override. So if you use override, every time you create the index, it will override the previous one. So let me just do override. Yeah, override. And again, these are all Boolean values. You're gonna just do true here. Okay. Now, what I'm doing, I'm very simple code. I'm doing rag engine.index, passing the input path, index name, store collections, override true. Now this is my document, and what I'm expecting is that it should create the index of it. Yeah, if you come down, you'll see it says added page 1 of document 02 in index. There are only 3 pages, if I'm not wrong, but you can bring up a lot of other pages. It says index exported to by ld index. Now, if you refresh this, you can find out a folder called by ld, and by ld. And if you just click on the index, you can find out the embeddings thingy over here. If you come down, you can find out. If you click on embeddings, you can find out embeddings 0.pt. Basically your vectors remains within it, guys. Now, what we're going to do next is we're going to create a text query probably. So let's create a text query. First, let's do the retrieval. First retrieval and then augmentation. So RAG is always a two process, guys. It's a two, there are two different processes within a RAG, at least minimum. When it's a RAG, it says retrieval augmented generation. So if you want to generate an answer from a given set of data, then first you have to retrieve and then you do some kind of augmentation to generate. That's what we do. So that's what it's called RAG, retrieval augmented generation. So it has two, at least minimum two, but you can bring up more layers into it. Now text query, let's have some questions. Okay, so what I'm going to do is let's look at this document. So I'm more interested to ask questions related to this image. So if you look at here, it says image from upper end. Let me make it bigger so you can see it a bit. And of course this document will be available on my GitHub repository. You can take it. I downloaded it from internet, by the way. It says image from upper endoscopic examination demonstrating a large ulcerated tumor in the body of the stomach. So that's an image, and I'm probably going to ask any questions related to it. Okay. Now, if I just come here and say, what has it written? Endoscopic. So I'm going to say, what does, upper endoscopic, let me see, endoscopic, something like that. Examination demonstrates in the body, something like this. Okay. Now I'm asking this question. Now you can see what does upper endoscopic. Now, if your model is not capable of encoding this particular image, it will not be able to retrieve. So the vision encoder is of course taking this image and of course creating a numerical representation of this particular image. Encoding is a fancy word, by the way. You are encoding a particular image or data that you have handy. Basically creates numerical representation so the machine can understand. When you want to do any processes on top of it. So if you come here, let me just run this text query. So this remains my text query, and I'm going to ask a result, and the result is like you have index in ColPali, you have a search module as well. So I'm going to do is rag engine dot search, and in the search you can pass your text query. You can see, let me just pass text query. You can also pass multiple. Okay, let me first do k equal to k is the top k document in how many documents or you want to fetch. So I'm going to say k equal to 3. And now let's run this. Once I run it, it will retrieve from the document that I have indexed. Okay, here. So let me just do that. Okay, now results, and let's just print the results here. Yeah, now you can see we are able to fetch the doc ID. Right now you'll not get the answer. We have to parse it, of course, but we're gonna do that now. So this is, you are able to fetch it. At least you have top k equal to 3 and you are getting the score. So you can see the score here, 23.25, 21.11125, and 18.125 with no metadata, of course, base 64 none. We not pass. Of course, we're gonna pass. We can also do that. Images indexing. Let's go through it. So what I'm gonna do is images, and that's we're gonna use uh, PDF to image. So we have convert from path, and we're gonna pass docs.pdf. Now the next what I'm going to do is image index. So image index, and within this image index, we're going to have our results. So let me just do results 0, and then you can see it has page number. So let's pass the page num, and then you can just, yeah. Now cool. Now what I'm going to do is I'm going to use a function for the augmentation. Okay. Okay, let me just also do one thing. So we need to write this. Yeah, you can see the image index 0. You need more document, guys. You need more document with more images into it. Yeah, but let's see the output now. So what I'm gonna do is I already have written a function that I'm gonna just import from here. Let me just do a raw, but we're gonna explain that. Here we're gonna passing the image index. You know, we're gonna pass the image, and you can see what we are doing. Okay, we are using Qwen-2-VL-7B, the auto processor, and then we have a pretty simple system prompt where we are doing, we are passing the image index, with these images. Okay, this can also return it, if you have, but I have tested only with single document with 3 pages, but I recommend that you test with n number of PDFs with which has multiple images, within it. Now, if you see here, it says image equal to images index, a pretty much simple system prompt over here. How do you pass? And then we are using chat template, over here. And then this is pretty much the old thing. Here we will not have model. We call it, what do we call it? We call it VLM or something. Okay, let me just come here to, and this becomes VLM. And these are pretty much transformers thing. Okay, what we are doing, we are, you know, I don't know why the hell it still but gives me, but this is what we are doing in taking the text, processing it, images, image input, videos, video input. This is pretty much Qn thing. If you look at my previous video, you will understand. And here we are generating the IDs, and then we decode the IDs to get the text out of it, and then we just print it over here. Max new tokens 50. You can increase it depending on the how much output you want. Let me make it like 100 or something. Now let's run this and see what happens. Now if you look at here, it says the upper endoscopic, and I'll make this a bit bigger so you can see it. Now it says the upper endoscopic examination demonstrates a large ulcerated tumor in the body of the stomach. This is great. Now, what we can also do, ask some other questions as well. So we have one more image. For that we can ask, some questions. Probably, uh, can we ask it from here or something? Okay, or ask something from reconstruction by a retrocolic. You know, uh, Let me copy this. Okay, and see if it's able to understand anything from here. So let me just delete this. Uh, what do we mean by, first we'll see this, and then I have one more question that I would like to ask. Okay, first let me run this. Let me just run this. Fantastic. Now if you look at here, it says a retrocolic, sorry, surgical procedure, blah blah blah. It gives you where a person is removed and remaining is connected to. Now if you look at the interesting thing over here, and if you come here, if you find out image index, now it returns 2. So it has find out the image, and you can return the image in your output as well. But what I'm interested more in, I'm gonna, and you can, of course, you can take this image index and return. But my main question is, I want to ask a summary use case. Let me see that if it's able to do it. So I'm gonna do is, what I'm gonna do, I want to test the model capability over here for a specific question. Summarize the case study in a paragraph with relevant images or something like this. Okay, let's see what kind of output I'm getting. At least want to see if it's I think it will fail when it comes to indexing the image for this particular question, because probably it's not able to find it will not be able to find out. Let's see that right now you can see it's it gives the image index because it has three images in it. Okay, you can see for this particular one, so 0. Now I understand, but let's see if it's able to get the text, if it's able to get the summary at least. That's fine. Okay, it says the case study describes a 76-year-old woman with a history of peptic ulcer disease who presented with intermittent chest pressure radiating to her back, and upper endoscopic revealed a large. Oh, you can see this over here, guys. An upper endoscopy revealed, and that's where you can return the image index. For this particular, like if you want to return it, and you can also do that now. Okay, this is cool. Okay, great. All right, guys. I think this is what I wanted to do in this video. Wanted to see how you can use ColPali to build very simple RAG pipelines using the vision language models like Qwen, and you can use any other models as well. I'll recommend to go through their documentations, the GitHub repository, their GitHub issues. You can learn a lot from the issues as well. So, and this notebook is available on my GitHub repository. Find the link in description. Now, if you have any question, thoughts, or feedbacks, let me know in the comment box. You can also reach out to me through my social media channels. Find those information on channel banner and channel about us. You can also join our Discord community. I'll give the link in description. A very growing community, for people across the globe that are joining it, helping each other. That's the community's community motto. Now, if you like the content, please hit the like icon. If you haven't subscribed the channel yet, please do subscribe the channel, guys. That motivates me to create more such videos. Thank you so much for watching. See you in the next one.